Hi, today I'm going to explain about alternating current circuit, which I will separate into four parts to explain. First will be AC sources, and the second one will be sinusoid waveform, and the third will be phasor and phase angle, and the last will be impedance. From the diagram shown, we can show that there is a comparison between DC and AC sources. The difference is say that DC sources, the battery voltage does not vary with time. The voltage remains the same for across the time, while AC sources, you can show that the voltage is changing across the time. It shows a wave form. Alternating current is the flow of electric charge that periodically reverse direction. And AC is produced by an alternating EMF, which is generated in a power point as described in induced electric field. Here is some example of AC sources, which shown is alternator, generator, and the inverter. The alternator is an electric generator that converts mechanical energy to electrical energy in the form of alternating current, while generator is a device that converts motive power into electrical power for use in an external circuit. Last will be power inverter or inverter is a power electronic device or circuit that change direct current to alternating currents. The slide shows the sinusoid waveform diagram, which tells you how to get the value from the wave. Sinusoid, a curve similar to sine function but possibly shift in phase, period, amplitude, or any combination thereof. Below shows the equation of the sinusoid. So at the right hand side there is a period formula. T is equal to 2 pi over omega, and T also equal to 1 over frequency. When we want to solve two sinusoids, we have to make sure their identities are the same. So using this relation, we can transform sinusoid from sine form to cos form or vice versa. Transform identities. In the diagram shows, we can use x-axis and y-axis to find the identities just now we used in the formula. If it is clockwise, we have to subtract the degree, and it is in anti-clockwise, we have to add. At A, we can show that if we want to change cos form to positive sine form, we have to subtract 90 degrees in order to change to the form of sine. While in sine, positive sine, we have to change to negative sine. We have to add up 180 because it is in anti-clockwise directions. Problem. Find the phase angle between I1 and I2. We can notice that I1 was in negative sign, so we have to change it into cos form by adding 90 degree. We will get the result 4 cos 377t plus 150 degree. So we can use I1 to subtract I2 in order to get the phase angle. Now I1 minus I2 will get the result of 155 degree. Now looking at the graph in the x-axis and y-axis, we can show that I1 is leading I2 by 150 degree in anti-clockwise. Phasor. Z can be represented in three ways, which is in rectangular form, polar form or exponential form. In the below, there is a graph that shows the complex number z and how to get the value in the diagram. R is equal to sud x squared plus y squared, and the theta is equal to inverse tangent y over x. On the other hand, if we know R and tangent and theta, we can obtain x and y as x is equal to R cos theta and y will be equal to R sin theta. Z may be written as z is equal to x plus jy equal to R theta or equal to R cos theta plus J sin theta. This slide shows the formula of Fraser. Addition, z1 plus z2 is equal to x1 plus x2 plus jy1 plus y2. Subtraction, z1 minus z2 is equal to zx1 minus x2 plus jy1 minus y2. And the multiplication, z1 multiplied by z2 will be equal to r1 multiplied by r2 theta 1 plus theta 2. In division, z1 divided by z2 is equal to r1 divided by r2 theta 1 minus theta 2. Sinusoid Fraser transformation from time domain to Fraser domain. Vm cos omega t plus theta is equal to Vm theta. Vm sin omega t plus theta will be equal to Vm theta minus 90 degree. So you can notice this is same as the changing unit in from sine to cos, that is minus 90 degree. The difference between Vt and V shall be emphasized. Vt is the instantaneous or time domain representation, while V is the frequency of Fraser domain representation. Vt is time dependent, while V is not. Vt is always real with no complex term, while V is generally complex. Practice problem. Express this sinusoid as Fraser. The A, since it is in cos, so we can directly take out the value and sub into the formula. So V is equal to 7 and 40 degree. And for B, you can show that it is in negative sign, so we have to change it into the form of cos by adding 90 degree using identities formula. After adding, we can directly get the value and sub into the formula, and the final answer will be I equal to 4 and 100 degree. Impedances have three elements, which is R, L, and C. R is resistor, L is inductor, and C will be capacitor. Each of them have their impedance formula. Z is equal to R, Z is equal to J omega L, and Z is equal to 1 over J omega C. This is example question. Find V naught T in circuit. Step 1. Change to Fraser domain. Vs is 20 cos 4t minus 50 degree. We can change into the Fraser domain. Vs is equal to 20 negative 15 degree. Omega will be 4. By using formula, we can find the inductor and the capacitor value. The capacitor value is equal to 1 over J omega C is equal to 1 over J omega multiplied by its unit. The final answer will be negative J25 ohm, while the impedance of inductor will be JWL and equal to J multiplied by 4 and multiplied by 5. The answer will be J20 ohm. Step 2. simplify circuit and use voltage divider to find V0. Now we can find out that Z2 is equal to J 100 ohm. By using the voltage division principle, V0 is equal to Z2 over Z1 plus Z2 multiply the voltage sources. Now we have to change the complex number form into Phasor domain in order to multiply and add up the degree. Now we can solve the result. V0 is equal to 17.15 and 15.96 degree. Now we convert this to the time domain and obtain V0 t is equal to 17.15 cos omega, which is 4t plus 15.96 voltage. This is example 2. In the circuit, we have to find out the I0. So I take one example A as the example. First step, we change to Phasor domain, which we will get 10 and 0 degree. Now we find the impedance of capacitor and inductor. Capacitor impedance will be equal to negative J20 and the impedance of inductor will be J1 ohm. Now step 2, we find the total impedance by adding up all the resistance, actually is impedance in the circuit, and the result we will get 2.136 and 22.04 degree ohm. Now by using the Ohm law, V equal to IR, I0 is equal to V over total impedance, which is equal to 10 0 degree divided by 2.136, 22.04 degree, and the final answer will be 4.68, negative 22.04 ampere. Now we change the Phasor domain into time domain, which IT equal to 4.68 cos t minus 22.04 ampere.